Hey folks, and welcome back. This is going to be our last video for this unit, so congratulations, you almost made it. This is going to be a lot easier than what we were talking about in terms of ionic compounds. Molecular compounds are pretty simple in terms of how you go about naming them. There's not a bunch of different complicated rules, so let's hop right into it. Just as a quick reminder, molecular compounds are compounds consisting only of nonmetals and sometimes metalloids. Remember, metalloids are the ones found right along the staircase, and they are held together by covalent bonds. And remember, in a covalent bond, valence electrons are being shared between the different elements, between the different atoms. It's not that we're creating ions by transferring electrons. Okay, so remember these GIFs where we have the electrons being shared in order to get full outer energy shells. Now, because there's a sharing of electrons going on here, right, we don't have to know the oxidation numbers. Okay, all you have to know are these Greek prefixes, and you need them for both the writing and the naming. So pretty straightforward. Let's get into what these Greek prefixes are. So there are 10 Greek prefixes that you need to know. These are prefixes. So prefixes, remember, go at the beginning of something. So these prefixes go before element names. All right. So you need to go ahead and write all these down. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay, so if you need to, pause the video and go ahead and make sure you write those 10 down. And then once you've gotten them all written down, we'll keep on going. Okay, so let's talk first about how to name the molecular compounds. First things first, we just got to add our Greek prefixes, again, before each element name or at the beginning of each element name. Now, the one exception to that rule is that you never add mono before the first element, but you always add mono before the second element. We're going to look at an example of that rule soon. The second thing we need to do, just like we did with the ionic compounds, we got to change the ending of the second element name to IDE. Okay, so you still have to go with that IDE ending on that second element, but because these are all nonmetals, right, it's not that we're specifically putting it on the nonmetal, we're just always going to put it on the second one. So let's take a look at a couple examples. C and O. Got to go to your periodic table. C is carbon, O is oxygen. Okay, now notice here that we have one of each of these. Okay, so we never add mono before the first element, but we always add mono before the second element. All right, so this is going to be carbon monoxide. We've got the mono, we're adding that to that second element, but not to the first one. All right, let's look at another example. We've got N2H4. All right, so we need to go back to our list of the Greek prefixes. All right, so N2. The 2 refers to the number of nitrogens. So how many nitrogens do we have? We got 2. Greek prefix is di. And then for the hydrogens, we've got 4. That's tetra. So this is going to be dinitrogen tetrahydride. Again, notice we've added the IDE endings to each of those elements. All right, so that's pretty straightforward, right? One of the things that can kind of come up when you're writing these is all of the Greek prefixes have endings that are vowels, and so sometimes you will drop those vowels if the beginning of the element name is also a vowel. So like notice here for the monooxide, right? It's not that we put mono and then we had 2 O's and then, you know, the second O was part of the oxygen. We just combine those together. So specific spelling, don't have to get it exactly right, but again, you'll kind of get a feel for how that is supposed to be put together as we do practice. All right, how do we actually write the molecular compound formulas? Well, if we're given the name is going to include the Greek prefixes, so that's just going to determine how many there are of each element. And that's all there is to it. So again, you just have to know your Greek prefixes. So example 1, we've got carbon dioxide. Okay, remember there's never going to be a mono in front of the first one. So if there's no prefix in front of the first one, you know there's only one. And then we have dioxide, right? So we have 2 oxygens. So that's going to be CO2. Remember, these subscripts always refer to the element that is in front of it. So you would write the CO with the subscript 2. Second example, we've got triphosphorus pentafluoride. Okay, so triphosphorus, that means that we have 3 phosphorus, and pentafluoride, penta is 5, so we have 5 fluorines. So it's going to be P3F5. Okay, and that's all there is to it, right? You just have to know your Greek prefixes, and you just have to be able to line them up properly. So here is your quick practice. I want you to submit these 5 practice problems today on Canvas. And so for these, if you're given the formula, find the name and vice versa. So 1 and 2, you're going to be writing the names. And then 3, 4, and 5, you're going to be writing the formulas. Okay, so pause the video and go ahead and answer these and submit them on Canvas. And I'll see you next time.